to Bites of Pi. Today we're going to be starting off the Elevens lab in the APCS lab series. One of the cool things I like about this is that we're going to learn how to program video games. Probably not this complex though. Everybody's got to start somewhere, right? And usually video games have their root in reality. So Elevens is basically about a version of Solitaire, which is a card game. So let's start off by asking, what is a card? Well, a card can be anything as long as it's like a piece of paper and it has something on it. So here's, for example, Rook. We have a Rook cards. They have numbers on them with colors, and they even spell out the colors for those of us that are colorblind. Yellow, even though it's kind of orangish. Phase 10 has a variation of this kind of thing. You know, just the colors and the numbers, 1 through 12, and they have wild cards and even instruction cards. We won't get into that. And Uno kind of takes a walk on the wild side. They also have that, but they also have wild cards and skip cards. They all have different things about them. Today we're going to talk about regular general playing cards. The game of Elevens is just like other solitaire games with a slight twist, and they usually use a pack of regular playing cards. So here I am with the regular playing cards. I'm taking it right out of the deck, and they look something like this. So when we start to program a video game, we start trying to get to the basics to say, okay, what's the core of the game we're trying to play? Now, Elevens is a game you can play in reality, but we're going to use a computer to do this. So there are when you look at all different kinds of cards from all different kinds of games, you notice three characteristics about cards. Usually cards have a suit, a rank, and a point value. And what do I mean by these three type of characteristics? Well, let's take suit. All right, a suit in a regular playing deck would be the way to categorize groups of cards. So here I can say, well, here I have one category of cards. They all have the same icon on them. This is usually called a spade. So you can see that there's an ace, 2, 3, 4, and they all share the same spade icon. So they call that a spade suit. The next suit here in a general deck is a diamond suit. You can see that there's a picture of a diamond, and they have cards from ace all the way through king in diamonds. Then they have clubs, ace all the way through king in clubs, and finally hearts. You can see the picture of a heart, ace through king. So that's what we call a suit. There's 4 suits in this normal deck: spades, diamonds, hearts, and clubs. Now, another characteristic we notice about cards are the rank. Now, the rank is what's printed out on the card. So you can see in a suit, each of these suits has the same set of ranks. So when I say rank, I mean ace, 2, 3, 4, 5, 6, 7, all the way, and then they have these additional cards, what they call face cards, which is a jack, queen, and a king. So that's what we mean by rank. It's what's kind of printed on that card. Lastly is the point value system. Now, some people will think, well, the rank is a point value, but that's not really the case. So if we take, say, for example, the game of blackjack, the ace can be a 1, or it could be 11. 2 is 2, 3 is 3, but then we have jack, queen, and king. Now a 10 is worth 10 points. A jack is worth 10 points, a queen is worth 10 points, and a king is worth 10 points. But if you were, say, to play a game like poker, the same set of cards, the point values would be different than what the ranks would be in a game of blackjack, because necessarily if I got 2 10s, it would be lower than 2 jacks or 2 queens. So I could necessarily give jack a higher point value than a 10. It could be like, say, 11, 12, 13. And in this case, instead of being 1, an ace would be the highest card, and we could rank that maybe a 13 or something, 14, sorry. So depending on what kind of game you play changes the point values of that game. Even though the ranks stay the same, the suits stay the same, the point values are different. So keep in mind these three different categories. So now that we have kind of defined what a card is and what a card game is, let's try and put that into a program. We're going to code up a card object. Oh, one last thing. Not only do I have a card, but I also have the concept of a deck. So here I have a deck of cards. This is what I mean by a deck. It's essentially a set of cards for playing a game, an entire set of a card. That's what I mean by a deck. In this program, in this lab, we're going to be coding up the card object and the deck object for our Elevens game. Turning over to our code here, let's take a look at the card. Again, here's what I was talking about earlier. There are three values: the suit, the rank, and the point value. We've chosen to use a string for suit and rank, and we've chosen to use an int for a point value. That way we can easily compare one card against another as far as their point value system. But a suit can be a string and a rank can be a string. Let's start off by coding up the constructor. Here, every time I want to create a new card, I'm going to pass it those three characteristics. I'm going to define the card's rank, the card's suit, and the point value of that card for this particular game. So all I need to do is store it in these three values. So that's fairly simple. All I need to say is this.suit equals this. There we go. This.suit equals card suit. This third time's the charm. This dot rank equals card rank, and this dot point value equals card point value. That was simple enough. I'm just storing the values. And here you can see it kind of truncated to this. I don't really need the word this. It just helps me do it with the autocomplete in Eclipse. We're going to skip matches for right now, but we're going to want to be able to compare one card against another. We're going to the easy ones. Here, we notice up here, one of the things I forgot to point out is the word private. Here, private means that I can only access these variables if I am a card. If I'm a deck, or if I'm a board, or any other program trying to access this class, I won't be able to do it. But I'm going to want to be able to get the card's suit, rank, and point value. I don't want the user to change those values, but I want them to be able to get it. So we have accessor functions. Now you've probably seen this in previous labs where we use the word get, like get point value or get rank. But the lab this time chose to not use the word get. So here it should be very simple. Every time we're going to return this dot point value. Every time somebody wants to get the value of the card, we're going to return that to them. Every time somebody wants to get the rank, we're going to return that value to them. It's fairly simple. And the same thing with suit. I'm going to return the suit of the card. When anybody wants it, they'll call this function and get the value. By doing this, we protect the values from being modified by the consumer, by the user that's going to use this object. But we can at least give that value back to them. Now we're almost done. We've stored the three characteristics of a card, but we want the card to do something else. We want two other things. We want to be able to print every time we call the card and say an output statement. We want it to print out a string. We want to create a string that will print out the value of the card, and we also want to be able to compare two cards together to see if they are equal or not. So let's start off with the toString method. Here in the comments you'll see the exact format of how they want the string to be created. We're going to use something that we haven't talked about before called a string builder. Now when you concatenate two or three strings, it's okay to use the plus sign to concatenate two or three strings, but it's more efficient in a lot of cases to use the string builder. So here I'm going to use the string builder to concatenate a whole bunch of values together. String builder sbret equals new string builder, and we're going to start with the open bracket, and we're going to start appending to that. So here, every time I want to do a concatenation, I want to use the word append. So I'm going to append rank, then I'm going to dot append the next string, which is close bracket of open bracket append suit. And because I'm lazy, I like to copy and paste a lot, so I'm just going to copy and paste this a lot. It's going to be string value, string value. So here I want to be able to put point value equals in between the suit and the next point value, and I want to put point value, and then I want to finish this off with a I want a parenthesis. So hopefully that'll print out in the exact format we lined up here with all these appends. So notice I've created the string builder, but Eclipse is still flagging me saying I need to return a string. So one extra statement I need to do is to return sbret toString, and that will return the new concatenated string. So hopefully it'll be nice and pretty. Alright, we're almost done with this class. One last thing we have to do is to compare. Now, one of the things when I'm comparing two cards, so a lot of people will just say, well, why can't I do this return this equals other card? Well, if you think about it, really what this is doing is it's saying, is the memory location of this, are they pointing at the same card? Well, when we're doing matches, we don't really care to see if they're pointing at the same card. We want to see if the characteristics of the card are the same, because I might have the same card twice. So I'm going to need to compare instead of comparing the memory location, saying this occupies the same space in memory as this, they could be two separate cards, two separate physical cards, but they could be the same if they share the same value, the same suit, and the same rank. So what we're going to do here is we're going to do this all in one statement. We're going to say if other card matches this card's rank, if it matches this card's value, and if it matches this card's suit. So we're going to do this all in one statement. I'm going to use this dot rank, and now this is a string, so I'll say if this rank equals other card rank, and if this, I like to copy and paste, this dot suit equals other card suit, and now I can do this because rank and suit are strings, but point value is not a string, so I can say this dot point value equals other card point value. Now, for those of you that are savvy, you're going to wonder, well, rank, suit, and point value are private. How can I call the private member of another card? Well, this is one of the weird things about private, is that I am in the object card. So if I'm talking about another card, I have access to that card's private members because I am card. If I was in any other place, I wouldn't be able to call this. I'd have to call rank function or suit function. And I can still do that too, but since I'm in card, I can also call the private members. And that's it. I've already implemented card. Again, I'm going to be prepared if you want to pause the video at this point if you wanted to take a look at the values of these. We're going to move on to deck. Alright, so now that we've coded up the cards, let's create a new deck. So there are certain characteristics of deck we want to implement here. Okay, here we have, let's look through the deck's code. First, let's take a look at the two members. Here we have a list of cards. This is a collection of cards. So essentially it's one right after the other of cards. It's what you would think a deck would be, is just a whole big collection of cards. The second thing we notice is the size. We're going to keep track of the not yet dealt cards. So essentially what that means is that if I have a set of cards and I haven't dealt anything else yet, it's going to be the full size of the cards. As I'm dealing the cards out to the game, I'm going to decrement or decrease the value of size until I've dealt everything out and size becomes 0. So keep that in mind when we go through this. One of the other things I like to point out, since you may be new to this, is this little open less than sign, greater than sign, and a value in here. This is one of the later things within Java. I think it was introduced in 1.5. Is called the concept of generics, where I can take different collections and specify. I can take a different object and specify what that object or collection takes in. So this will become more apparent. It helps when you're coding and be able to use different collections of classes, and be able to specify and be clear about what that collection provides. We won't get into that for this video. So let's start off by creating a new deck. That seems pretty simple. First we're going to create, this is not initialized, essentially it's null, but we're going to initialize it here. So we're going to say cards equals new array list card. Now, if you were to look at a list in Java, a Java list, you'll notice that it's not an actual class, it's an interface. So I can't create a new list of cards. I have to create an implementation of list. List is just a definition of how a specific collection is used in Java. There are different types of lists, but the most common is array list. So we're going to be creating a new array list of cards. Now notice it's highlighting me here saying that I haven't imported anything yet. So here you can see that all I have is Java util list. If you're in Eclipse, all I need to do is hit Control-Shift-O, and it automatically drops it in there for me. It says, hey, there's only one object that I know that has an array list, and that's this Java util array list. If you're still using JGrasp, you're going to need to type this in. All right. So now that we've created that, we have to add new cards. So let's do that. So I'm going to use an enhanced loop. I'm just going to say, put some comments here so I can keep track of my code. Loop through cards, loop through ranks, suits, and values, and create cards. I like doing this kind of pseudocoding, kind of writing up what I'm going to do before I do it. That way I can keep track of what I need to implement as I go along. So I'm going to loop through a list of ranks, suits, and values and create cards. Then I'm going to want to capture the size of the deck. Finally, I think at the end of this constructor I'm going to want to shuffle. And that's just a placeholder here, but I'll just say shuffle. I'll also call shuffle. I'm going to start from this end. Now we are not going to call shuffle in this lab, but we will get to shuffle in the next video. So now that I've got my little pseudocode here of what I want to do, I want to loop through the rank, suits, and values and create cards. So how do I do that? I'm going to loop through. Now let's take a look at suits, ranks, and values. Suits are hard, and in this case that we're working with right now, we're using a generic set of cards, a generic set of playing cards, in which we have 4 different suits: the hearts, diamonds, clubs, and spades. So I'm going to loop through each suit, and for each suit I'm going to loop through the ranks and the values, and then create a card for every rank and every suit. I'm going to create a new card. Now ranks and values are pretty much tied together. So while there's only 4 suits in a playing cards deck, there's usually ace through king in ranks. And so we're going to assume that position 0 of ranks is going to match the point value of position 0. So as we're looping through, ranks is going to match values. So At position 0, it's probably going to be rank is going to be ace, and we're going to assign that 1. Position 1 is going to be a 2, and we're going to assign it 2, and so on. So keep that in mind as we go through this loop. For string suit in suits loop. All right. Now that we've done that, we're going to want to loop through the ranks. For int I count equals 0, I less than ranks dot length I count plus plus. All right, so we're going to loop through that array and start creating cards. So I'm going to do this all in one shot. So I'm going to take the cards list and I'm going to add a new card, and I want to pass in ranks.I count. Almost messed up there. Count suit, and then values I count. Again, I want to keep ranks. The matching rank is going to match the value that's in this array. Close that off, save that out, and we're good. But suit necessarily won't match rank and value. Okay, now we've captured that. We're going to loop through all the suits and then create a new card for every suit. Alright, now we're going to keep track of size. So size tells me how many cards have not been dealt yet. So if I'm starting off the game with a new deck, I haven't dealt any yet. So I want the size to be the cards.size. Now, one of the things I didn't mention in playing cards is that a playing card deck has 52 cards. So if, in essence, if you counted up ace through king and multiplied times 4, you'd get 52. So I'm going to refer to 52 frequently within the next couple of videos. So you'll know that 52 essentially is the number of playing cards in a regular deck. Alright, let's do some of the easy ones now that I've got the constructor out of the way. Here's the isEmpty. Well, actually, we're going to, yes. The isEmpty is when all the determines if the deck is empty, making sure all the cards have been dealt. So the only way we can determine that, we're going to return if size equals 0. So if size equals 0, that means we've dealt everything, there's nothing left to deal, everything's good. That seems pretty straightforward. And remember our semicolon. Next thing is our accessor size. Return size. That seems pretty straightforward. I just want to return the size at whatever point it is. Shuffle we're going to leave for later, and toString it's already been done. So we've got one last function to implement, and that is deal. So what do we want to do in deal? Well, first off, we want to idiot-proof it. A lot of the things we want to do in our code is to make sure that if people are given an option or a chance to do something, they will do it, and it'll cause your code to break or crash the system, and we don't want to do that. So in order to kind of idiot-proof the system, we're going to check to make sure that the deck isn't empty, because we can't deal from an empty deck. If the deck is empty, we're going to get an out of either an array index out of bounds error or a null pointer exception. So in order to protect against that, we want to say if size, or actually if is empty, if we've already implemented is empty below, if the deck is empty, we want to return null, saying, hey, there's nothing left to deal, it's done. Now we're going to pseudocode this out. I should have pseudocoded it before. Here we want to return card off the top of the deck. if you've ever dealt in a card game before, you normally deal off the top of the deck. So we're going to kind of simulate that by doing that off the top of the deck. If deck is empty, return null. Return null. So we're going to do that in a couple steps. This return the card off the top of the deck. The deck is return cards.get, and here we're going to put size. But if we think about it right here, we want to return the size, and we want to decrement, because we're dealing decrement size. So we also want to decrement the value of size. Now, if you remember back to Java arrays really go from 0 to size minus 1 of the array. So if I was to just leave it as it is right now, it will give us an out of bounds exception, because if I say this is 52, it'll try and get card 52 when really there's only cards 0 through 51. So I'm going to need to decrement size right away. Now, there's a difference between minus minus size and size minus minus. If I was to do this right here, it'll decrement it to 51 and then return 51. If I was to do this and put it here, it'll evaluate size before the minus minus and say return card 52, which will cause an out of bounds exception, and then decrement it. So in this case, we want to decrement it. The positioning of the minus minus matters. We're going to decrement the value of size before we evaluate it and send it back to the function, rather than the other way around. Play around with it. You'll see that it'll fail if you do it the other way. Okay, so now we've implemented deck and card. Let's create a tester that will test both deck, what we've done so far with deck and card. So first, let's put little pseudocode here. What we want to do with this deck tester. First thing we want to do is create suits, ranks, and cards, and point values. We're then going to want to create a new deck. We're then going to want to deal from that deck. Deal a few cards from the deck. Actually, we're going to want to do something before that. So we'll print out the size. Print out size of deck before we deal. We want to deal a few cards. Then we're going to want to print out the size of the deck after dealing. So make sure that that dealing function works, and that it actually changes the size. And finally, we'll just call deck to print out the full deck. So let's see what we need to do here. Alright, we know that suits and ranks are string arrays. So we're going to create a new string array for suits. And we're going to initialize that to hearts, clubs, come on, third time's a charm, diamonds, and hearts, clubs, diamonds, and spades. Right, that's what we want. Alright, we've got our suits. Now we want to do our ranks. So let's do ace, 2, and I'm going to 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So we'll do 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Alright, so we got our ranks. Now we're going to want our points, our values. So it's essentially all of this, but we're going to say 1, comma 2, comma 3, comma 4, comma 5, 6, 7, 8, 9, 10, and we're going to want, in this game of 11s, we're actually going to assign Jack, Queen, King a value of 0, and that'll make sense later on. Oh, one other thing, it's not string, it's an int array, not string array. Alright, so I've got my suits, ranks, and values, so I'm going to create a new deck. Deck equals new deck, and we're going to pass it, I think it's ranks, suits, values. Now, one of the troubles of programming is to remember, shoot, which order do I need to pass the values in? Well, one of the cool things, if you develop the code, if you hold the control key down in Eclipse, it turns everything into hyperlinks. So I can click on this and see the constructor. It has ranks, suits, and values. So I know I have this in order because I've got ranks, suits, and values. Ranks, suits, and values. Yep, there we go. Alright, so we're going to print out system.out.println print line. I'm going to say deck has blank cards. I'm going to fill this thing in with deck.size. Okay. I'm going to do this before and after, so copying and pasting makes it really nice. Alright, so now I'm going to print out the size before and after, and now I'm going to want to, I just got dealt. We're going to want to deal a few cards. A, not insert, delete. I want to do a deal. Instead of a size, I want to deal a card. And I'm going to do this a couple times so I can get a couple cards from the deck. Alright, so I created a new deck, print out the size of the deck, dealt myself a few cards, print out the size again, and last I just want to print out the deck. Alright, drum roll, let's see what happens. Hopefully everything runs smoothly. Alright, and it did. So here I can see that the deck has 52 cards. Oh, I should have put a couple of nice print lines here. Let me do that. System.out.println. There we go. Print with a T. Print out that and that, so I have a nice space. There we go. I start off saying I've got a deck of 52 cards. I dealt out a king of spades, queen, jack, 10, 9, 8, all of spades. And now after I've dealt it out, now I've got 46 cards. And then when I print out the whole deck, it tells me if size is 46, the undealt cards are all of these, and the dealt cards are these. Now if you take a look, you'll notice there's a pattern here. You notice it starts up, I deal king of spades, queen of spades, jack of spades, 10, 9, 8, 7, 5, 7, 6, 5, 4, 3. It's going in order. And one of the things about card games is that you need to have a chance of randomness. Otherwise, you're going to be able to predict the outcome of every game. So let me try this again. Same thing. King, queen, all this of spades. What I'm missing here is the shuffle. If you remember back to the deck constructor here, I had this function called shuffle, but it's not implemented. So in the next lab, we're going to cover different shuffling algorithms and how to make sure that you can shuffle your cards so you can't predict the outcome of the game. Thanks for watching, and I'll see you next video.